Hi, in this lecture we are going to be seeing an example for naive Bayes classifier in Python. So in this example we are going to be looking at how we would use naive Bayes classifier, and we also will be looking at how we can do text pre-processing, which is to convert a body of text into a TF-IDF matrix. The input for this is a list of messages, like SMS messages, and each of these messages have been already classified for you as either ham or spam, and we are going to use this data set to build a naive Bayes classifier for spam filtering for SMS messages. So how are we going to do it? We are going to start with importing a bunch of these libraries and then changing the working directory to the working directory of the naive Bayes algorithm. And then we're going to be loading this file called SMS spam shot. This is available as a part of your resource bundle. And let's look at what data we have in this file. It's basically just two columns. One column which is the type, whether it is ham or spam, and the next is actually the SMS text. When you do a describe, you won't get anything pretty much because it is just text data for you. And then when you do a data.head, when you look at the top 5 rows, this is how the data pretty much looks like, and the text you would see is the text messages in there, and then you have the type, which is ham or spam. To convert it into a TF-IDF vector, there is already a library available within sklearn, and this is called TF-IDF vectorizer. So we are just going to import that library and start using it. We first create a corpus from the spamdata.text column. So the spamdata.text is what will become the corpus of text that is going to be now vectorized. And then we are going to then call TF, we are going to initialize the TF-IDF vectorizer. And when you say stop words equal to English, it's basically identifying the language that you would be using for stop words. So it already comes with a standard set of stop words, which would try to eliminate it automatically. And then on this TF-IDF vector, we just call fit transform of the corpus. We just call vectorizer.fit transform on the corpus, which is all the text message, and that would give you the TF-IDF matrix. So pretty simple, straightforward. Let's look at how the matrix looks like. The matrix, you can see, is it has 500 rows and 2034 columns. There are 500 rows with each row corresponding to one text message, and there are 2034 columns because each of the word that is identified in the body of text becomes a column. So you have 2034 columns and you have 500 rows. Typically, when the message set is large, the number of columns will also become large, in which case you might try to do some variable reduction or feature selection on this to reduce the number of columns to those that occur more frequently. Given that our data set is not that big, we are just going to leave it as is. And then the regular modeling and prediction steps follow, which is separating the predictors and the targets, then separating the training and test data sets. So this is pretty much following the same steps that you already might have seen with decision trees as well as linear regression. So you're going to be splitting the predictors and targets. The predictors, of course, is the TF-IDF, the entire TF-IDF table is the predictor, and the target is the type variable. And then you're going to be using the training testing split 70-30 to split it into the training and testing predictors and targets. And then you can look at all the shapes, which is pretty much 350-150 split that you would see there of the content. The algorithm is actually implemented for you in this naive Bayes library within sklearn. You import the Gaussian naive Bayes library for this purpose. The Gaussian naive Bayes library does the regular naive Bayes classification. So you open the classifier by just calling classifier equal to Gaussian NB, and then you call the fit method to actually build the model. From the fit method, you pass the training predictors and the training targets, and that would build a classifier for you. And for predicting, we are going to predict on the test predictors. So it's the same step, predict on the test predictors, and then you're going to be calling the predictions command, and then the predictions are there for you. And this prediction is nothing but a classification of whether each of the 150 records in or 150 messages in the test data set, it is classified as either ham or spam. And then you can do the usual confusion matrix in there, and the confusion matrix shows you how predictions are happening. So pretty much when it is a ham, which is the 116, pretty much is predicted pretty accurately. It is spam where there should be some amount of confusion in trying to predict the spam messages, because out of I think the 31 spam messages, 18 are predicted as ham. So the accuracy of spam messages is not that great with this specific algorithm. And the next question you might ask, even though you look at the overall accuracy numbers, the overall accuracy number is 85%, but that is because you are predicting all your ham messages correctly, and ham messages are most of the messages. That's why accuracy might be high. But when you look at identifying spam messages, it is not that great, because there are like 31 spam messages and only 13 are identified as spam. So there are a number of ways you can improve upon this. Given that you have 2034 classifiers, maybe you can then filter only on the top 10 or top 20 classifiers based on the count, and then try the model again. You can try other methods. You can try some bagging and boosting methods also to see if that improves the predictability of the spam messages. But this is what is the outcome of using naive Bayes on this specific data set. It might be possible the data set only has that much amount of messages to classify it correctly. So this is how you do text TF-IDF generation and then use it for naive Bayes. Thank you.